Hey everybody, just a quick review of the concept of a relation and a function. We talked about it yesterday, but repetition is good, so let's talk about it again. So we're talking about relations and functions, and a relation, as you remember from yesterday, is basically just a set of ordered pairs, as you can see here, any set of ordered pairs, and of course we know that an ordered pair, when we say ordered pairs, we're talking about two numbers, x and y. And so this ordered pair is 2, 1, and this ordered pair is 4, 2. This one right here is 0, 5. So that's what a relation is. And it could be any number of ordered pairs. This one has 3, but it could be a whole lot more or even fewer, but at least 2. So a function is a special type of relation, and in a function, it's basically a relation in which each number in the domain, you remember that's x, is matched to exactly one output in the range. And so when we say range, we're talking about the y coordinates. So here are some examples of actual functions, relations that qualify as functions. This first one over here on the left, you can see, is a function because I've got 3 matched with positive 3. I've got 4 matched with negative 1. The number 5, as you can see, is matched with 11. And the number 6 is paired up with 7. So each of these 4 numbers has only one output that it's connected to. Over here on the middle part, when we have this graph, we can see that each ordered pair has a unique x and y value, so that if I tried to draw a vertical line, at no place would a vertical line pass through any 2 of these. And then lastly, this is just a list of ordered pairs here, unlike this mapping diagram. This right here is a mapping diagram. But this right here is just some ordered pairs. And again, 2, if the input's 2, the output's 1. If the input is 4, the output is 0. When my input is 5, the output is 1. And then if the input is negative 1, the output is 0. There's no duplication of any of the inputs tied to a different output. So what we've got there is actually a function. So here are just 3 quick examples of non-functions. First off, over here in this first one, we see that this is not a function because the input value 3 is tied to both an output of 2 and an output of 4. Even though 4 only goes with 6 and 5 only goes with 4, the fact that 3 has 2 outputs means that if this were a machine, it's not functioning very well. This is not a function. In this middle part, the graph, I've got all these ordered pairs, but you can clearly see that if I drew this vertical line right here, that vertical line would actually pass through 2 points. And so for whatever this value of x is, I've got 2 different values of y. And that means that just like over here in the mapping diagram, I've got one x that's connected to 2 y's, so that if I put in 3 cups of flour in my bread machine, I might get 2 loaves of bread, or I might get 4 loaves of bread. Here, if I ask what happens if x is my input, I get 2 different answers. So this is not a function. And then lastly, if we just look at not a function. This last one is not a function very simply because 3 is matched with 2, 4 is matched with 5, 5 is matched with 1. We look at these, and then 4 is also matched with 0. So what happens if x is 4? What's y? Well, y is 5. Or if x is 4, y is 0. That's 2 answers. That's just like having these 2 points. It's just like having these 2 arrows in a mapping diagram. And so this, again, is not a function. I hope this makes sense. We'll talk about it again soon.